My name is Jobe. I'm going to be talking today about this thing I've been working on called Faux threading. These slides are available here. You can follow along on your mobile phone. This is an HTML slide deck that I created, so we can all kind of follow along. Let's see here. So faux, fake, imitation, McLovin. I don't know if you guys get this reference, but he's trying to pull it off. This is what faux threading can do, and I'm going to, if I have time, show you a demo of every one of these things. You can execute functions without locking up the browser. You can execute multiple functions at the same time. This is without web workers, by the way. You can execute AJAX without any callback, so you kind of escape callback help. You can suspend execution of a particular function until a particular expression yields true, without, again, having to do any callback. So, your code's running, and then it just waits. It waits for a particular thing to be true, but control goes back to the browser. There's some other things you can do here. Hopefully, I'll have time to show you. But the threads themselves can talk to one another. So unlike a web worker that's kind of isolated on a separate thread, these threads have full access to one another, as well as the DOM, as well as themselves, which is a good and a bad thing at this point. It's still kind of early. But they can actually alter the, when a function is running in this mode, it can alter its own body while it's running. So it can actually mutate what it's doing while it's executing. Okay, demo time. Okay, so here's a quick function. Hopefully all you guys can see that. Does everyone see that okay? Okay, so this is a very remedial function. It's just a while loop. It counts up from 0. Bart's done some bad things, so he's writing to the wall here. But he's got to write quite a few sentences. And so if we run this in the browser, it's just going to hang, right? Because the code never gets back to the browser. It's that while loop that starts counting up to about 10 million, and it never goes back. So Chrome is just going to sit here and not be completely non-responsive. So I was thinking, wouldn't it be cool if there was something we could do to this function where we could just kind of wrap it in some magical tag, and all of a sudden it would be parallel. And so that's what faux thread does. So if we sit here, okay, I'll do this. Yep. I even made a little note to myself down there. Include faux. Okay, so we save that, and then we run. Now I got a pop-up block here because the faux thread actually debugs. It's going to show you a little bit of, I guess you'd call it like pseudo bytecode. So there it goes, and it runs. Basically what it's doing is it's translating the body of that function by converting it into a string, and then reparsing it, and then kind of transpiling it into this pseudo Java code that is like single line execution. So that's just a very simple demo. This thing's still running right now, and it will continue to run and pollute the global namespace until we stop it. Meanwhile, the other one is still hung. So that's one example. Let's get some other demos here. Here's an instance where we have two functions running at the same time. We've got Bart and Nelson, and they both have to write to the global namespace. So if we run this and unblock our pop-ups, we'll get two compiled function bodies that are running, not really in parallel. This isn't a true concurrency thing. So it's not running kind of like step 1, 2, step 3, 4. It's kind of like an eeny, meeny, miny, mo. Because every line within the body of the function is being executed, and then controls being passed back to the browser. That's how you can kind of allow this to be refreshed. It's kind of like having a set timeout loop or a set interval loop in your code. Okay, and then for this third demo, I need to launch a little server that I wrote. This is just going to handle GET requests. So I can show you, hopefully, what this guy There we go. Okay, so here's a third example where Bart doesn't really want to write his sentences, so he just goes and gets Millhouse text and returns that to the body. But he wants to wait for Millhouse's response. But there's, as you can see, at least on this layer, there are no callbacks. You simply have an await keyword, which is common in some other languages as well, and that essentially just sits and polls the XML HTTP object, looking for a particular ready state and response state. Anyway, I'm getting the 5-minute mark, so I'm going to run this demo quick, and then I'm going to get out of your hair here. There we go. So you can see that the code was converted and then executed, and this is actually the text of Millhouse. Anyway, so that's it. And hopefully I can maybe come back when we've got some more time to show you how it all works. But that's all I have for you today. So if you have any questions, my name is Spencer, and you can get all of this stuff. Let's go back here. Ready. So if you want to download the code, it's right there. It's not on GitHub yet because it's pretty hacky code. I'm sure most of you could probably do a better job writing it. The slides and an email address you can reach me at. So thanks for your time.